today. Okay. We have three different types of functions that you need to be able to tell which one is which. I'm getting very frustrated. Thank you. We have a linear function. Hey, guess what? It looks like a line. I'm going to skip to this third one. We have a quadratic function. It looks like a parabola. And then we have this exponential function where, just like in the data we looked at, it starts to get bigger, but then the further we go, the bigger and bigger and bigger it'll get. So notice how both 2 and 3 were increasing. It increases slowly and then it gets big fast. Okay. So what we need to be able to do is we need to be able to determine if we have a linear, exponential, or quadratic function. Okay. So in a set of data, if we have a linear function, then the differences in our y values are going to be constant. Okay. What does that mean? Let me show you. Okay. We're going to draw this right here. So I'm going to have you draw an XY table. Okay. I want you to draw this XY chart. Okay, so what do you notice about the x coordinates? Okay, and that's good. We need to have a consistent by the same number in order for this to work. Okay, now what do you notice about the y coordinates? 11 to 8. How do we get to 11 to 8?
3.
And what about 8 to 5?
3.
What about 5 to 2?
3.
Okay, do you notice how we subtract 3 every time? If we are subtracting or adding the same number from y value to y value in our chart, we have a linear function. We have a constant rate of change. Okay. Now, in an exponential function, our consecutive y values are going to have a common ratio. So this is what I want you to draw for this chart. I want you to draw this XY chart, please. What? Yeah. Okay, so notice how our x's increased by the same number. We need that to happen with whichever table we are looking at. Okay, but what's happening in our y's? Do you notice how we are multiplying by 2 every time? Okay, since we have, this is called a common ratio. I multiply by 2, by 2, by 2 to get to the next one. If we are multiplying by the same number over and over, we have an exponential function. Okay. Okay, and then a quadratic function. Hey, that's what we've pretty much been dealing with for the past 3 weeks. Okay. I don't know. Kind of feels like it, doesn't it? Well, we have a test on Wednesday.
Is this gonna be like something we need in high school?
Yeah. Our last test
Oh, yeah.
will be the last Friday of school. Yeah.
I learned that one.
Okay, please write this down. We're gonna look at a quadratic example.
You think I would be carried?
I just don't even know anymore. Okay, so notice in this example, our x's are consistent. Now, are we multiplying by the same number over and over with our y's? No, but here we go down by 1, and then we go up by 1, and then we go up by 2, and then we go up by 5. Is that right?
Sure.
Yeah. I think it's linear. Wait, what? What's that be?
No, it's +3 for the.
Oh, man.
Yeah, I was trying to.
Is that better? Okay, so now, but if we look at this, if we look at these numbers right here, to get from -1 to 1, that's up by 2. To get from 1 to 3, that's up by 2. To get from 3 to 5, that's up by 2. So when we look at those second differences and they're the same, then we have a quadratic function. Yeah. No, not in this class.
We'll have to do it eventually.
Like x to the 5th?
No, but like go like.
Oh, like with this pattern? No. No.
I was
Yeah, you're wrong. I didn't do that, LOL.
That's funny. All right, so what I want you to do I want you to go 2 pages. So turn the page and we're going to look at this number 5.
You can look it in her eyes.
Okay. I would like you to figure out what kind of function we have in number 5. Is it linear, exponential, or quadratic? Figure it out. Don't guess. Do you even know what I asked you to do? What did I ask you to do? Nope. You to figure out if number 5 is linear, quadratic, or exponential. This is your last chance. If I have to address you 4 one more time during this class period, we are getting a new seating chart. And you will all be at a different table from each other. That would affect everybody's table. Okay, raise your hand if you vote that this is a linear equation. Quadratic. Exponential. Okay. 7 to 4 is down 3. 4 to 1 is down 3. 1 to -2 is down 3. -2 to -5 is down 3. We have a constant rate of change. This is a linear. This is linear. Okay. I'm going to be a little crazy. Are you ready? Can you please change this 6 to an 8? And can you change this 6 to an 8? And I want to decide what number 6 is. Because I wanted to.
That's easier.
Who votes that this is linear? Good answer. Who votes that this is exponential? Who votes that this is quadratic? Okay, so good. Our x's have that consistent up by 1, up by 1. Here we have 4 to 2 is -6. 2 to 0 is -2. And then we go up 2 and then we go up 6. Well, if we look at the second differences, -6 to -2 is up 4. -2 to +2 is up 4. 2 to 6 is up 4. This is a quadratic.
It was nothing. That's why I didn't like it. It would have been nothing.
I know, I didn't like it, so I changed it to what I wanted. Okay, now, just to end out our time together, do you have any ideas about number 9? You think so?
Linear.
Quadratic.
Okay.
Check
Okay. Abby, could you take 305 minus 289 on there's a calculator right in front of you. Okay. Can you take 289 minus 241? Here? Here?
112.
Ah.
Exponential.
I don't think it was quadratic.
It's gotta be exponential. Okay, you have a book assignment. It's already on Google Classroom for you.